next challenge is entitled Sock Pairs. Joseph is in the middle of packing for a vacation. He's having a bit of trouble finding all of his socks though. Write a function that returns the number of sock pairs he has. A sock pair consists of two of the same letter, such as AA. The socks are represented as an unordered sequence. See the examples below. AA, the two A's match, forming one pair of socks. The second example, we have an A in the first and third position, that makes one pair. We have two B's in positions 2 and 4. I was using one base number in there. So we come up with two pairs. The C doesn't match with anything and so doesn't contribute. We only have two pairs here. And then you can see in the last example that we have two A's, we have four C's, and two B's, which works out to 4 pairs. Notice that we had 2 pairs of C's, and that's how we got 4. You count each pair. The notes say if given an empty string, no socks in the drawer, returns 0. There can be multiple pairs of the same type of sock, such as 2 pairs of CC for the last example. So we already saw that. I think we can go over to code now. This is your chance to pause the video and come up with your own solution. Come back when you're ready. So for this problem, I'm going to introduce another data structure that's useful. This one's called a hash set. We definitely haven't used that in any of these Edabit series, so we'll do a little introduction to that. This is quite an oversimplification of what a hash set is, but it says it represents a set of values. In this case, when they say set, they mean distinct values, and you can see that in the remarks section below. A set is a collection that contains no duplicate elements, and whose elements are in no particular order. So that's the set part of it, and then you see how it makes a comment about having high performance set operations. That sort of comes from the hash part of it. This is a hash set. And you've probably heard of hashing. If not, that's okay. But essentially, hashing allows you to treat objects like integers. So if you can think of the arrays that we used previously, we could just specify any location we wanted to go to and get the data there immediately. For example, you can say array with square brackets 4, get the memory at index 4. And so a hash set kind of mimics that speed in that it'll take an object that isn't an integer, it'll run it through something called a hash function, which basically turns it into an integer that can access memory. And if you're thinking, if problems are jumping into your head, that's good. It's not as simple as that, right? You can have what are called collisions, where hash functions turn 2 different objects into the same index value. And so there are different strategies for dealing with collisions. That's outside the scope of this exercise here, but we'll definitely get more into that. If you happen to know what a dictionary is, you can think of a hash set as a dictionary without the values. I think that's the way they described it in the documents too. Yeah, can be thought of as a dictionary, which is sort of a mapping between a key and a value. Like you might think of a phone book would have a name to a phone number. And in this case, the hash set is just like that, but the key kind of doubles as the value. It's kind of like a key value all wrapped in one. So that's a quick rundown of what the hash set is, and I'll try to show you how it's helpful in this problem. Maybe not the best solution, but I saw an opportunity to introduce a new data structure and I thought that would be helpful. So let's get into matching socks. I'm going to keep a counter here that's going to increment our pairs as we find them. And then my strategy is going to be to iterate over this collection of socks. Every time I find one, a new one, I'm going to put it in my hash set. And if I look at my hash set and find that there's already a sock of that name in there, I'm essentially going to take it out of my hash set and increment my number of pairs. That's going to be my strategy for this problem. So let's make that hash set. And we're dealing with a string, so our underlying type is going to be char. We know a string is a collection of chars. And let's call this, it's going to function as unmatched socks the way I'm using it. And we're going to instantiate this class, new hash set. You have to instantiate it before you use it. So there we go, we got an empty hash set of type char, unmatched socks. So now I'm going to go over the collection. And normally I do char ch, but I'm going to try and give a more appropriate name here that might make it easier to read, and you should be doing that too. I'm going to call it sock, because each character is representing kind of like the name of a sock, right? A, B, C, but we're thinking of them like socks, so I'll stay with that. In socks, now, the deal is we receive a sock for each iteration of this loop. The first thing I'm going to do is check to see if my collection already has one of these socks in there. Of course it doesn't the first time around, but I'm coding this in general. So the hash set has a method contains for doing this. So I can say if unmatched socks contains sock. That means I already have, say, a letter B, and then this sock I encountered was a B. That would be a match. So I'm going to denote the match by incrementing my num pairs. And then I'm going to say unmatched socks, remove the one that was in there. The hash set class also has a remove method for taking elements out. So I had my one in there, and now it's empty, so there's no socks of that type anymore. I made a match, so I'm eliminating it. I claimed that lone sock for my match, and that's why I'm removing it. That's how I chose to think about this problem. And then otherwise, assume that your collection does not have the sock that we're analyzing right now. Then we're simply going to add it to our collection. Unmatched socks, add the sock. And then it'll have that one entry, maybe a letter C. It's going to be in our collection now for the next time we come through the loop, and then maybe we do get a C. And then we're going to match, increment the number of pairs, remove that sock from the collection, and keep going. I think that's clear. And then you can imagine after all this processing is done, after we've analyzed all of the socks, you can simply return your num pairs. And then the hash set, we probably need system collections generic. Of course we do. So we'll put that back. Make sure we have that using statement. System collections generic. Okay, that should cover the hash set. And then again, if you want to look at the class, where is it? It's nice on the left here how you can go to methods, you can expand it, and you'll see we should do properties. We used a property too. Or maybe we didn't use count in this. Contains is what we used to check. So you see contains here, click on that to read about that. We added and we removed. So you can look those up if you like. Other than that, I think we can give this a run. Okay, got an error on line 3. unexpected symbol, public. Oh, I see what I did. Feel free to pause the video if you'd like to figure out the problem. So, as nice as these error messages can sometimes be, you can see the problem didn't actually happen on line 3, though I see why it would list that. I didn't put a semicolon at the end of my using statement, so yeah, that's bad. Everything just runs together otherwise. So cool, we matched all of the socks. We made the method determine how many pairs are available. So again, this was your intro to hash set, maybe the concept of hashing. Basically create a pool of unmatched socks. You know, imagine you're folding your laundry. You encounter that one weird Christmas sock, so you kind of put it on the bed in its own little pile. And you do that with all the other weird socks, your Argyle ones, whatever. And then as you find the pair, you match them together. Maybe you roll them up together and you put them in your drawer and they're gone. You know, that's kind of what we did here. Went through all the socks. If we didn't have it in our pile, we made a pile for it and then matched them as they came up. Increment the count along the way, and then by the time you've gone through all socks, simply return the number of pairs. So yeah, probably better solutions out there. So do share what you come up with, and otherwise I'll see you in the next video. Thanks.